Assalamualaikum warahmatullahi wabarakatuh. This is our presentation for separation process. Our title is refined hydrocarbon production of 150,000 of MTA through crude oil distillation. These are our team members: RIDZUAN bin RAHMAN, NORAINUN binti Muhammad SABRI, FAREESYA binti Muhammad FARID, and NADIATUL HUSNA binti Muhammad HELMI. So first is for introduction. So oil refining refers to the process of converting crude oil into various useful products as crude oil made up of hydrocarbon. Therefore, industry separate it and further manufacture various products to meet industrial, commercial, and consumer needs. Crude oil is composed of as crude oil fraction are separated first by distillation, which involve separation at various temperature. So with time, the introduction of cracking has made the process advance a little, wherein heavier fractions could be converted to the lighter and higher value fractions. So there are four major refining process: distillation, cracking, reforming, and uh, treatment. So for the distillation, we separate even crude oil into the fraction based on boiling point. Cracking is convert heavier fraction into lighter and more valuable product. Reforming improve fuel quality by restructuring hydrocarbon molecules. Next is treatment to remove impurities to make product specification. So this is our application for the refined hydrocarbon fuels. First is transportation fuels, like gasoline, diesel, and jet fuel. So gasoline is used mainly in automobile. Uh, Gasoline is one of the largest petrol products that come from crude oil distillation. Diesel is utilized in heavy-duty trucks, railroads, and marine vessels. Diesel is obtained from heavier crude oil of fraction. Next is jet fuel. Jet fuel is aviation that requires special kind of kerosene-based fuel for aviation. So uh, heating oil used in household and commercial installation. Uh, Next is LPG. Uh, LPG is clean burning for fuel for heating, cooking, and as vehicle fuels. Next is industrial application. So industrial application, naphtha. Naphtha is petrochemical feedstock in manufacture of plastic and synthetic rubber, also and chemicals. Asphalt is for road construction and roofing materials, especially due to its durability. So this next is overall process and synthesized route. First, for the overview, crude oil is heated at 350 to 600 degrees Celsius in a furnace. Uh, the heated crude oil vaporized and enter the distillation column. Fractioning process is vapor rise. They cool and condense at a different level based on boiling points. Later fractions such as gases, petrol, and condense at the top of the column. On the other hand, heavier products fractions such as diesel, residual and residual oil collect at the bottom of the column. Next is conversion. Conversion like cracking. Uh, After fractioning, it is necessary to further treating some of this fraction into more valuable types such as cracking, reforming, alkylation. So cracking in this widely used method break down the larger hydrocarbon molecules into smaller, more valuable ones like gasoline and jet fuels. Cracking employs heat, pressure, and catalyst to facilitate this deformation. Reforming, reforming is a process that rearrange hydrocarbon molecules to improve their quality particularly for producing high octane gasoline from naphtha. Alkylation is a combined gaseous byproduct from cracking to create gasoline component, effectively reversing the cracking process. Next is treatment. After all the conversion process are done, the various refined products are treated to market specification. So the treatment process is desulfurization. This is an important process in removing sulfur and other impurities in order to product to comply with the environmental regulation. Next treatment is blending. Where blending is process from the various steering units are blended together in order to get the desired characteristics such as octane rating for gasoline and vapor pressure ratings for fuels. Uh, After all of the treatment, there is final stage is storage. In the final state, the final treated refined product are stored in the big tanks or before distribution. For the storage tank, the tank are built to handle a range of product in a safe manner and are often placed near the refinery for the biological for refinery near the refinery for logistical refine efficiency. Next is distribution. The various refined products are then pipeline, trucked, or railed to other markets within the region.
For process description, crude oil is transferred from storage where sediments and water are removed. It is then heated from 120 to 150 degrees Celsius using recovered heat. So the process is from desalting. Crude oil is mixed with water and exposed to an electrostatic field for droplet coalescence, removing salts and emulsions to prevent corrosion. Next, heating in heat exchanger. Crude oil is preheated by exchanging heat with hot product streams, improving energy efficiency before entering the furnace. And the next, heating in furnace. Preheated crude is heated to 330 to 385 degrees Celsius in the furnace to partially vaporize for distillation. Next, atmospheric distillation. Vapor enters distillation column where steam strips like hydrocarbons and stripping section. Steam removes lighter hydrocarbons from heavier fractions, enhancing separation. And then overheat condensation. Vaporized like hydrocarbons are condensed into liquid using heat exchanger and condensers, separating products like naphtha. And last is vacuum distillation. Atmospheric residue is processed under reduced pressure, separating lighter vacuum gas oils and heavier residues for further processing. This is a process flow diagram of an atmospheric distillation unit that we retrieved from a journal. Units operation. So for desalting, the operation of desalting is crude oil is mixed with water and exposed to an electrostatic field, causing water droplets to coalesce and separate by gravity. So the function is to remove salt and water in oil emulsion. And then heat exchanger, which is hot product streams transfer heat to the incoming crude oil to raise its to improve energy efficiency. So the equipment is series of heat exchangers. And the next for furnace, the crude oil is heated in a furnace to the required temperature for partial vaporization before entering the distillation column. So the equipment is fired heater designed to handle high temperature without excessive cracking. And then distillation column. So the vaporized crude oil rises in the column where it condenses at different tray levels based on boiling point, separating into different fractions. So the function is to separate crude oil into fractions, which is gases, naphtha, kerosene, diesel, gas oil based on the boiling points. And then stripping section, which is the steam is injected at the base to lower the boiling points of the remaining hydrocarbon, aiding in separation of lighter composition. So the equipment is trays located at the bottom of distillation column to enhance separation by using steam to remove lighter hydrocarbons from heavier fractions. And then overhead condenser, the vaporized light hydrocarbons at the top of the column are cooled in the condenser, turning them back into liquid from liquid form for the collection. And then equipment is heat exchanger and condensers. It condense vaporized like hydrocarbon into liquid products like naphtha. And the last one is vacuum distillation unit. So the atmospheric residue is heated under a vacuum, lowering the boiling points of heavier fractions, which are then separated into lighter and heavier products. So the equipment is vacuum distillation column with trays or packing to minimize pressure drop, and processes uh, atmospheric residue under reduced pressure to separate lighter vacuum gas oils and heavier vacuum residue. So the raw material is crude oil, which is the primary raw material, which naturally contains water, salts, and a mixture of hydrocarbons. So these impurities need to be removed through desalting and other treatments before distillation to ensure the efficiency of the refining process and to prevent equipment damage. And final product are gases like methane and propane, like straight run naphtha, heavy gasoline, kerosene, diesel, heavy gas oil, and atmospheric gas residue. So for cost analysis, there are estimated costs for units, raw material, and final products. So table 1 shows estimated cost for units. There are every cost for every units involved, and the total is 53,823,750 billion. And then for raw material, crude oil can cost approximately 667.8 per barrel because it is estimated to cost 4 ringgit 20 cent per liter. So for a 150,000 MTA refinery, the cost of crude oil can be approximately 1.5 billion annually. So for final products, the gases valued at 3 ringgit per kilogram, light straight run naphtha priced at 3 ringgit 50 cent per kilogram. For heavy gasoline sold at 4 ringgit 20 cent per kilogram. Kerosene priced at 5 ringgit per liter. Diesel cost 4 ringgit 80 cent per liter. Heavy gas oil sold at 2 ringgit 80 cent per kilogram, and atmospheric residue priced at 2 ringgit 50 cent per kilogram. That is the price for heaviest fraction left in the distillation unit.
Next, for the distillation unit, the basic operation of the crude oil distillation operate at temperature 350 to 450 degrees C under atmospheric or slightly reduced pressure with the vacuum distillation used for heavier fraction. The process separate hydrocarbon based on their boiling point, producing light products such as the propane and gasoline. The middle distillate like the kerosene, jet fuel, and diesel, and heavy component like the lubricating oil and alphate. The feed rate measured in the metric ton per annum that indicate the volume of the crude oil process. The crude oil consists of 80 to 85% of the hydrocarbon, including the alkane and cycloalkane, and the aromatic with the impurity such as the sulfur, nitrogen, and trace metal, which vary by the source. Distillation aim to separate this component efficiently with the light product refined for purity, middle and heavy product meeting specific performance standard. The figure shown is the schematic diagram where crude oil is heated and separated into various fractions based on their boiling point. The light products are collected at the top where the start with the feed and enriching section go through with the condenser and reflux drum, and then they distillate at the top where can produce the gasoline, LPG, naphthalate with the purity 85 to 95%, while the heavier components are drawn from the bottom will have the lubricating oil, fuel oil as valid, while the reboiler and heat out the product middle distillate such as the kerosene, jet fuel, and diesel. The process involved with the control temperature and pressure at maximize efficiency. Like at the reboiler, they use the 673 to 723 Kelvin and 1 atm. Each fraction is further refined to meet their specific industry standard.
For part 3.3, I will talk about the design procedure of a distillation unit. The design procedure for a distillation unit in the refining oil process involves a series of systematic steps to ensure that the unit is capable to efficiently separating crude oil into the various components. So we have 13 steps that we need to take into consideration. So the first step is to clearly define the objective of the distillation unit. This involves the understanding of the specific products needed and their required purity levels. Analyzing the crude oil properties such as its composition, boiling point, range, and impurities helps to set the foundation for the design. Next is the requirement analysis. This includes product specification, throughput, and energy efficiency targets. Additionally, the design must comply with industry regulations and safety standards to ensure both operational efficiency and environmental protection. Next is the preliminary design. It means that the basic structure of the distillation process is outlined. Engineers should calculate the mass and energy balance and choose the type of column based on factors like separation complexity and cost. This provides a framework for the detailed design, and the detailed design involves calculating the number of stages needed for effective separation using methods like Mercapture method. Engineers then design the column's internal components such as trays or packing material and determine the appropriate column height and diameter to handle the required capacity. Then the next step is thermal design. Thermal design focuses on the energy aspect of the unit, particularly the reboiler and condenser. Engineer designs these components based on the heat detail required. They also consider heat integration to optimize energy use, reducing operational costs by recovering heat within the process. The next step is choosing the right materials, which is crucial for durability and performance. Materials must withstand high temperatures, pressure, and corrosive conditions typically encountered in distillation. The selection balances performance, cost, and longevity. In order to maintain the stable operation of the distillation unit, a robust control system needs to be applied. Engineers design systems to monitor and control temperature, pressure, and flow rates. Safety mechanisms such as pressure relief valve and emergency shutdown system are also integrated to prevent hazards. Following this process simulation tools like SPAN HUSNA used to model and validate the design. And then this allows engineers to test different scenarios and optimize the unit's performance, making necessary adjustments to ensure the efficiency and product quality. And comprehensive documentation, including detailed drawings and specification, is prepared. This documentation is essential for construction, operation, and maintenance, ensuring all aspects of the design are clearly recorded. And step number 12 is commissioning and startup. During commissioning, the unit is tested to verify that it meets all the design specifications. And finally, regular monitoring and maintenance ensure the long-term performance of the distillation unit. Continuous performance reviews and optimizations help maintain efficiency and adapt to changing operational needs. So I'll talk about the challenges of having distillation column. So the first one, since distillation is a big equipment, so its operational costs are a critical consideration, as refiners must balance the need for high quality output with cost efficiency. Next, managing the high energy demand efficiently, ensuring that the process remains cost effective while meeting production, is another challenge for this unit operation. Third one is the presence of various hydrocarbons and impurities such as sulfur compounds require careful management to ensure that effective separation occurs. The fourth one is we need to maintain operational stability in distillation column because issues like foaming, cooking, and falling that may happen during the process. So it is challenges for distillation. And then the last challenge for distillation is to achieve the desired separation efficiency in order to produce high purity fractions. So these all are the challenges of distillation. So in this part, I will talk about advantages and disadvantages of distillation column. Firstly, the advantages of distillation is the process results in high purity levels for individual components. Next, distillation column can be scaled up or down to fit different product requirements. And also, this unit operation is ideal for separating and purifying complex mixtures as they are highly efficient. Distillation also suitable for a wide range of mixture and products in different boiling temperatures. And then, it can operate continuously, which is beneficial for large scale production. So, what is the disadvantages of distillation? The first one is very high energy consumption because it consumes a significant amount of energy to heat, cool, and condensate the vapors. And then, since distillation is a big equipment, so the cost of purchasing and operating can be high due to the need of precision equipment and instrumentation. Next one, the design and operation can be complex and requires specialized knowledge and expertise. It can require significant maintenance and downtime due to its complexity. And then the last one, the energy requirement and the potential release of emissions into the environment can have a negative impact. So that's all for advantages and disadvantages of distillation column. So 3.4 is the material balance of distillation unit. And overall material balance in the top section of the ratifying operating line is represented by the column, the stripping operating line by the bottom section, and the feed line equation by the feed stage balance. Using these operational lines, using all these equations, we may calculate the number of streams entering and leaving the column. So you can see in the figure, it is the fractional distillation column diagram. So the first one is we need to have the overall material balance, which is V equals to L plus T, and then it will be expanded into each material balance, and then we can have the rectifying operating line. And in terms of reflux ratio, it is made because of an assumption of constant molar flow, which is L0 equals to L1 equals to L2. So the equation will be expressed in terms of reflux ratio. So the next one is stripping operating line. Also same steps as rectifying operating line, and then we have the stripping operating line equation. The third one is the feed line. So for an overall material balance at feed station, it gives that F plus V M plus 1 plus Lm equals to V N plus 1 plus Lm. So after doing some mathematics, we have the feed line equation as in the slide. So the fourth one is another line that needs to be calculated, which is the Q line. Q line is the liquid content of the feed, which can be represented by Y equals to Q over Q minus 1, X plus XF over Q minus 1. And then the last equation that we use to calculate the minimum number of theoretical trays, which is N minimum equals to that equation. So the next slide will be the graphical representation using McCap-Taylor method. And after we have all the value of X and Y in the equation, we can use it to plot the graph, and we will have 4 lines, which is operating line, stripping line, Q line, and rectifying operating line. So that's all. So for the factors that affect the operational cost and also the potential strategies to reduce the cost, we listed 5 in the slide, which is the first one is the energy consumption. It is a significant cost in crude oil distillation owing to the heating and also the cooling operations. So we recommend to recycle heat from hot product streams to preheat incoming crude oil so that it can greatly reduce the amount of fuel required for heating. The next one is the maintenance and repair. A predictive maintenance schedule can assist identify and address possible problems. So by regular cleaning and service of equipment, ensure that the machine runs at peak efficiency, lowering energy usage and also avoiding costly repairs. So for the next one is labor and utility costs. Training employees on best practice and process efficiency can reduce downtime and increase the production, whilst automating routine operations reduce labor costs and increase consistency. So, efficient utility management, such as recycling water and steam and improving auxiliary systems like cooling towers and compressors, helps to cut resource usage even further. So the next one is environmental compliance. Effective emission control systems can help reduce this cost by installing system for flue gas desulfurization, wastewater treatment, and emission control can reduce environmental effects while avoiding fines and penalties. The last one is in aspect of technology and equipment. So retrofitting old equipment with energy-saving technologies such as modern heat exchanger or high-efficiency distillation column can help improve overall process efficiency. And then, by improved catalyst and separation technologies can increase the product yields by decreasing energy requirement per unit of output.
So this is our conclusion. Primary separation process based on boiling point difference are formed the backbone of refining process for operation, producing fuels such as gasoline, diesel, and jet fuel. So the critical refining step of separation immediately and suitably segregate the various components include at the same time optimizing the downstream such process such as cracking and reforming for maximum yields of desired product with market demand. So further in advance in distillation, uh, technologies and energy optimization have enhanced distillation roles in achieving operational efficiency and compliance with current environmental concerns. So for to conclude our project, the separation process therefore play and in this what I call it, the important role in a modern refinery and provide the base to convert crude oil into many high value products for industry, transport, and for daily needs. Thank you. That's all from us.